Hello guys, welcome to my YouTube channel. So this is mathematics paper 1. It's a revision. So if you're new to this channel, subscribe for more videos. So the question is saying simplify r minus 3s minus 3t minus 4r plus 10s plus 8t. So here in this case here we have three variables. The first one we have r, followed by the next one, which is s. Then the last one, it is t. Okay, so we need to correct them likewise. So we have r. So r is a like term to negative 3r. So in this case here we have r minus 4r minus 3s. So 3s is a like term to positive 10. So I'm just going to say negative 3s plus 10s. Then we also have minus 3t, which is this one here. So negative 3t is a like term to positive 8t. So plus 8t. Then from there now, we are just going to say r minus 4r, we are going to get negative 3r. Then negative 3s plus positive 10s, we are going to get positive 7s. Okay. Then negative 3t plus 8t, we are going to get plus or positive 5t. So in this case, if you like, you can start with a positive number, whereby you say positive t, let me say positive 5t, then you say minus 3r, and then plus 7s. Then at the end, you write your answer here. So in this case here, our answer, it is 5t minus 3r plus 7s. So this one is our final answer. Let's try to look at the next one. So the next one is saying factorize completely 2c to the power 2 minus 8cm minus 3cm plus 12m squared. So when you're factorizing, you need to group the terms into two. So I'm just going to group these two into two. Okay. In these two, it is 2 is common. Okay, so 2 is common. Apart from 2, c is common. Here we are having c squared, and then here we are having c. So c is common. So we can just say what is common in these two, it is 2c. Meaning with c. Then minus 2c into negative 8cm. The answer is going to be negative 4m. Then close. Then from there now, what is common in these two here? It is negative 3m. Okay? So m here is common, even here m is common. And then also 3, which is negative 3, is common. Right. Then open bracket. So negative 3m into negative 3mc. The answer is going to be positive c. Then 12m squared divided by negative 3m. The answer is going to be negative 4m. Then close. So as you can see here we have so which means I'm just going to pick one, which is c minus 4m. Then from there now I'm going to subtract these two here because of the sign here. Okay, so here we have 2c, which is this one, then minus the sign here, then we have 3m. So this one here is our final answer. Now at the end, we need to write our answer here. So open bracket, we have c minus 4m, then close, We also have 2c minus m, let me say minus 3m, then close. So this one is our final answer. So let's try to look at the next one. So the next one is saying, which is question 3, evaluate the square root of 3 to the power 4. So when you have something like this one here, 3 to the power 4, it's more like you are multiplying 3 times, let me say you are multiplying 3 4 times. 3. Now how many times? 4 times. Like this one here. Now remember here we are having the square root. Even here we need to introduce the square root. Now 3 multiplied by 3, that is 9. Multiplied by 3 multiplied by 3, that is 9. So 9 multiplied by 9, that is 81. Now the square root of 81, it is 9. So this one here is our final answer. The next one. So the next one is saying, solve the equation, which is question 4. Solve the equation. We have open bracket, x plus 5, close bracket, to the power 2. Okay? Is equal to 1 over 9. So the first thing here, what I'm going to do, I'm just going to write this one here. So we have this one here is equal to 1 over 9. And then from there now, the next step here, we are just going to introduce the square root to both sides. So once I introduce the square root to both sides, I'm going to find that the square root and these two here, they are going to cancel each other. Then here I'm just going to remain with x plus 5, then close, is equal to the square root of 1, it is 1. Then the square root of 9, it is 3. So here we have this one and also this one. So to find or to solve this equation, I'm just going to balance this one by 1, then close multiply. So we have 3 multiplied by open bracket, x plus 5, close, is equal to 1. Because 1 multiplied by 1, it is 1, which is this one here. Then from there now, we are going to say 3 multiplied by x, we are going to get 3x. Then 3 multiplied by positive 5, we are going to get positive 15, is equal to 1. Okay? Then from there now, let's find the value of x. So when positive 15 crosses an equal sign, it is going to change to negative. Okay, so here we are going to remain with 3x is equal to 1 minus 15. 1 minus 15, it is negative 14. So we have 3x is equal to negative 14. So 3x is equal to negative 14. Then since here we are finding the value of x, which means I'm just going to divide by 3. Even here by 3. So 3 and 3, they are going to cancel each other. Then the value of x is going to be negative 14 over 3. So this one here is our final answer. Right. Question 5. Question 5 reads, shade, open bracket, q, complement. So this one here means complement. So we need to shade q intersection, let me say q complement intersection p, close bracket, union r on the Venn diagram in the answer space below. So we are just going to use this one here to shade. Specifically, let me explain on this part here how to shade. So when you have two sets, like when you have q and p, this says this one is q and this one is p. Then here we are having the Venn diagram. If they say shade q complement, shade q complement, which means you are going to exclude the set of q and shade the intersection of what? Of p. So when you have been told to shade q complement, you need to shade this part here, right? But if they tell you to shade q, so if they tell you to shade q, which means you need to shade this part here, the entire union part of q, right? we need to exclude union Q, because here they have put it a complement. Okay, so we need to exclude the part that I've circled with apple green. Okay, then the next one is saying we need to shade the intersection P. So now what is our intersection P? So intersection P is this part that I'm shading here. That's the intersection P, okay? Without touching Q, right? Then let's come to this one here. This one is union R. So as for union R, it is this part here that I'm going to shade. So when you shade something like this one, which means you are done. The next one is saying, if A is equal to, open square bracket, -2 by 1, 5 by 0, close square bracket, and the matrix B is equal to 0 by 2. Find B transpose. So whenever you see something like when you have been given a matrix and then a matrix is having to the power capital T, that one is going to represent a transpose. Okay. So a transpose, what usually happens during a transpose is that the rows are going to become the columns and the columns are going to become the rows. Find B transpose. So B transpose is equal to, which means this one here, 0 is going to maintain its position, then 2 is going to become the column, like this one here, okay? So let me use the square bracket. So that is how we are supposed to answer as the transpose. So this one is the transpose of B. So here our final answer is just going to be 0, then 2, answer question B. So to answer question B, the first thing you need to write the order of matrices. So the order of matrix A, it is 2 by 2, okay? So it's 1, 2. The rows are 2. What about the columns? They are also 2. 1, 2. So it's 2 by 2. What about matrix B? So matrix B is having 1, 2. So in this case here we say 2 by, then the columns are just 1. So it's 2 by 1. So now if you're having the numbers which are similar in this case here, which means these matrices, they can multiply each other. And the product of the matrix that we are going to get, it will be these two here, which is 2 by 1. Right? So let's answer. So we have the first one here, which is matrix A. So our matrix A, it is -2 by 1, +5 by 0. Then matrix B, it is 0 by 2. Okay? So from there now we are just going to multiply. -2 multiplied by 0 plus 5 multiplied by 2. So this -2 is multiplying with 0. Then +5 is multiplying with +2. Right. Let's come to this one. So on top here we are done. Let's come to this one here. So similarly on this part here, 1 is going to multiply with 0. And 0 is going to multiply with what? 2. So we have 1 multiplied by 0 plus 0 multiplied by 2. So from there now, -2 multiplied by 0, we are going to get 0 plus 5 multiplied by 2, we are going to get +10. Then 1 multiplied by 0, we are going to get 0. So this one is 0 plus 0 multiplied by 2, we are going to get 0. So 10 plus 0, we are going to get 10. Then 0 plus 0, we are going to get 0. So as you can see, the final answer, it is 2 by 1. So let's prove that one. So we have 1, 2. Right? What about the columns? We have 1. So this one is 2 by 1. Likewise. So our final answer, it is just 10. So it is just 10 by 0. So this one is our final answer. Question 9. Question 9 is saying, given that the universal set, so capital letter E denotes the universal set, okay? Capital letter A denotes the universal set. So in the universal set here, we have numbers from 1 up to 8. Then we have set A, which is 1, 3, and B, 2, 5, 6, 7. And then the question is saying we need to list A complement intersection B. A complement intersection B. So to answer this one, let me just draw a Venn diagram. So if this one is our Venn diagram, then we have two sets. We have set A and also set B. So the first thing, you need to start with the numbers which are common in these two. So as you can see here, they don't have any number which are common in them. So as for A, we just have 1 and 3. Then as for B, we have 2. So we have 2, 5, 6, and 7. Now, according to the universal set here, we have 1 up to 8. So which numbers are missing from these two sets? It is 4 and 8. So 4 and 8 should be outside the sets. So we have 4 here and 8 here. Right. So now, here they have said we need to list it. Here they have said we need to list A complement intersection B, like this one here. So if we exclude the members in A, okay? If we exclude the members in A, what members are we going to remain with? We are just going to remain with these members here. So now, as you can see, you need to start with the smallest number. So we can say A complement intersection B is equal to, open curly bracket. So the smallest number here is 2, followed by 4, 5, 6, 7, and 8. So this one is our final answer. So we are saying the answer is 2, 4, 5, 6, 7, 8. So that's all for question A. Then as for question B, solve the equation. So we need to solve the equation. So solve the equation. So we have 2 to the power x minus 1 is equal to 1 over 8. So the first thing here, we need to convert this one here into a negative index. So once we convert this one into a negative index, it is going to look like this. So it will be 8 to the power negative 1. Then from there now, we need to make sure that the bases here are the same. So we can convert 8 into base 2. So we can just write this one, 2 to the power x minus 1. Then this one is going to be like 2 to the power 3. Because 2 to the power 3, it is 8. Now, here we are having negative 1. So we need to open the bracket. Then we put negative 1. So if these bases cancels each other, here we are going to remain with x minus 1. Then here we are going to remain with 3 multiplied by negative 1. So we are remaining with x minus 1 is equal to 3 multiplied by negative 1. That is negative 3. Then x is going to be, when this negative 1 crosses an equal sign, it is going to change to positive. So we have negative 3 plus 1. Then the value of x is going to be negative 2. So this one is our final answer. So the value of x here, it is just negative 2.